Shield agents have created an underwater bunker to hold various technologies. It is 8 meters deep with isosceles endings that have a width of 5 meters and a height of 2 meters. The water fills this trough at a rate of 6 meters cubed per second. So what you want to find is at what rate is the height changing when it is at 1.2 meters. So first we do a sketch. So we have our depth, which is 8 meters, and we have our width, which is 5 meters, and we have a height of 2 meters fully, but we want to find it when it's at 1.2 meters. And so you can write out to the side what you know. So we have the rate, which is 6 meters cubed per second, and the width, which is 5 meters, and the depth, which is 8, and we have our height, 1.2 meters. What we need to know is the change of h. So the change when it's at 1.2, so we're going to find the derivative of h, of the height, which is the change of the height. And so our equation is going to be area of the ends and the depth. And since our area of the ends are isosceles triangles, we know that it's 1/2 base times height times depth. And if we plug in what we know, we have 1/2 height times width times 8. We're going to know the height, which is 1.2 meters. But if you simplify this, it's going to be 4 times height times width. So what we need to do is get rid of the extra quantity. We need to get rid of this w right here. And so it needs to be eliminated. If we use the similar triangles at the ends, then we are able to set up a ratio using this. So the ratio is going to be width over height equals height over 2, which is going to equal, in turn, 5/2 times height. And then we're going to plug in this ratio to the problem we found before. So 4 times height equals 5/2 times height, which equals 10 heights 2. Now one of these heights, when we differentiate, is going to be just the differentiate height, so the change. So we're going to find, when we differentiate, it's going to be 20 times h, and then we're going to multiply that by the change of h. So we're going to try to isolate this change of h. So if we plug it in, it's going to be 6 equals 20 times 1.2 times the change of height, which equals 0.25 meters per second. And so we find that the height of the water is rising at a rate of 0.25 meters per second when the height is at 1.2 meters.